Hi guys, in today's video we're going to look at polarized ions and then we'll look at an exam style question.
So before we start, I just want to have a look at the relative size of our cation, our positively charged ion, and our anion, our negatively charged ion. Well, our cation is formed through the loss of an electron, and the ionic radius of our cation will be significantly less than the atomic radius of the element. Whereas for our anion, we have gained an electron, so the ionic radius is going to be significantly larger than the atomic radius of the atom it was formed from. So if you look at their relative sizes, the anion is much larger than our cation. So let's have a look at how ionic bonds can be polarized. Well, in an ideal world, we might expect ionic bond to look like this, where the electron clouds of our cation and anion are discrete. However, it often ends up looking a lot more like this, and you can see the electron cloud of our anion is being drawn towards our positive cation, and we have a distorted bond where the electron cloud of the anion is indeed drawn towards our cation, and we can see how the bond has a degree of covalent character. So the polarizing power of our cation depends on many factors, and we'll have a look at those now. The first factor is the radius, the ionic radius. The smaller the radius, the more polarizing the cation, and that's because the positive charge of the nucleus will be felt more strongly when there's a smaller radius. The charge is also a significant factor determining the polarizing power of our cation. A larger charge will mean our cation is more polarizing because there's a stronger attraction for the outer electrons. Now, both these factors give our cation a high charge to size ratio, or a high charge density, and that's what makes our cations more polarizing. In terms of our anion, there are certain factors that make them more polarizable, if you like, and that's they have a larger radius, and that's because the electrons in the outer shell will be held less tightly and therefore are more prone to being drawn towards our positive cation.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.